Okay, students, today we have another method of differences idea. This is including three terms. Okay, like the previous one we took when we have like fr minus fr plus one or something like that, like including fr and fr plus one. Today we'll be taking terms including fr plus one, and fr plus two with different coefficients. So it's essentially the same idea, but here we have to put like 4 to 5 cases, like where r equals 1, 2, 3, 4, 5, then see a pattern, because normally there's not really a fixed rule for every single one of them. Like we could have different a, b's and c's and the different stuff, yeah. So let's see. Let's take this example. First, we would do the partial fractions. UR equals 1 over r plus 1, r plus 2, which is equal to 1 over r plus b over r plus 1 plus c over r plus 2. Therefore, a times r plus 1 1. Obviously, we just multiplied both sides by the denominator, so this one will be 1, and this one will be like this. So let's expand and compare coefficients. 2a equals 1, meaning that a plus b plus c times r squared plus 3a plus 2b plus c r plus 2a equals 0r squared plus 0r plus 1. Therefore, we wanna like equate the coefficients only. So we have a plus b plus c equals 0, 3a plus 2b plus c equals 0, 2a equals 1. Therefore, this is a system of three equations of three unknowns, and we want to see how we can solve it. We open our calculator, we put three unknowns, and we just insert them. B equals -1 and c equals half. So the calculator is pretty much like our savior here. It helped us a lot, obviously, in of course saving time also. So now let's get back to the question. UR equals half 1 over 2r minus 1 over r plus 1 plus 1 over 2r plus 2. Now we wanna define fr as a function. Now what would this function be? Simply, it will be 1 over r, since all the r's are in the denominator. Therefore, fr equals 1 over r, and fr plus 1 equals 1 over r plus 1, and fr plus 2 equals 1 over r plus 2. Therefore, ur equals half r minus fr plus 1 plus half fr plus 2. So how can we solve the summation question, all of it, or the sigma question, all of it? Basically, we just, as I said, we see the first 4 or 5 cases and we see a common thing in them. So sigma r equals 1 and ur equals half f1 minus f2 plus half f3 plus half f2 minus half sorry minus f3 plus half f4 plus half f3 minus f4 plus half f5 plus half f4 minus f5 plus half f6. Now let's see what would cancel completely. We have the first half f1, of course, it will not go, but the f2, what would happen to it? This half f2 will be gone, and this will stay minus half f2. Okay, what about the rest? Let's see. f3 will go with this one, and it will stay here minus half f3. Okay, and if we continue one step, we will see that it will also cancel here, and f4 will also partially cancel. We will have minus half f4, which will completely cancel with this one. f5 will be the same. Therefore, at the last term, if we stopped here, let's say we stopped at this step, okay? Let's just get back 2 steps and see what happens if we stopped at this step. Okay, if we stopped at the fourth step, of course, we have half f of 1 minus half f of 2 plus 0, since this was cancelled and negated, okay? And 0, 0, 0, 0, minus half of 5 here will take down this half, okay? And the minus f4 here will be taken all down. Therefore, what do we have left? We simply have left, of course, this is the nth step, okay? Like this is fn, and this is half fn plus 1. This is half fn plus n plus 2, meaning that we would have half f1 minus half f2 minus half fn plus 1 plus half n plus 2, and that's it. This is the answer, and thank you.